Do you remember when a single architectural rendering could take days to complete? The client is calling for presentation visuals by tomorrow morning. The render farm is maxed out, and your team is pulling another all-nighter staring at a progress bar. That scenario has defined the pace of architectural practice for decades. But right now, a tool is emerging that has the potential to rewrite that story entirely. It is called ComfyUI. And in this video, we're going to walk through, from the very beginning, exactly how it can transform your rendering workflow, shaving days of work down to minutes without sacrificing the precision and control that architecture demands. Before we dive into the tool itself, let us address the obvious question. With Midjourney, Adobe Firefly, and ChatGPT image generation, all available right now, why bother learning ComfyUI? The answer comes down to one word: control. Midjourney is a tool for receiving images. ComfyUI is a tool for designing them. For architects and interior designers, a beautiful but unpredictable image is nearly useless in professional practice. What you actually need is a rendering that respects your floor plan geometry, reflects your specified materials accurately, and holds a precise camera angle. ComfyUI's node-based workflow puts every one of those parameters directly in your hands. Across the global architecture and design industry, forward-thinking studios are already integrating these workflows into everyday practice, and the gap between those who have made the shift and those who have not is widening with every project cycle. When you open ComfyUI for the first time, the canvas fills with boxes and lines, and it can look intimidating. But the underlying logic is genuinely simple, and once you see it, everything clicks. Think of it like a Revit or BIM family structure: individual, reusable components that connect together to form a larger system. In ComfyUI, each box is called a node, and each node performs exactly one function. One node loads your image, another accepts your text prompt, another renders the result. The lines connecting them are called edges, and they represent the flow of data moving from left to right through your pipeline, culminating in a finished image on the right side of the canvas. The complete arrangement of nodes and edges is your workflow, and a well-designed workflow, once built, can be reused across every project, shared with your entire team, and adapted in seconds. To get started, you only need to understand three core nodes: the clip text encoder, the K-sampler, and the VAE decoder. These three form the skeleton of every image generation pipeline in ComfyUI, and everything else builds from there. Now we reach the feature that transforms ComfyUI from a general-purpose image generator into a genuine architectural rendering tool: ControlNet. The fundamental idea is this: you take a drawing or model view that already exists in your workflow, whether it comes from AutoCAD, SketchUp, Rhino, or any other platform, and you hand it directly to the AI as a structural reference. The AI then generates a photorealistic rendering that respects and follows that geometry, rather than inventing something from scratch. ControlNet offers three modes that are particularly powerful for architectural applications. Canny mode reads edge lines and outlines. It is the ideal match for line drawings, technical elevations, and hand sketches. Depth mode analyzes spatial depth from a 3D view, preserving the sense of volume and distance, perfect for massing studies and early-stage spatial exploration. Normal map mode reads surface orientation at a finer level, allowing the AI to render material textures with exceptional precision, invaluable during facade and finish review stages. In practice, you export a scene from SketchUp, connect it to ControlNet, and in moments you have 10 distinct material and finish options ready for your client presentation. The meeting dynamic changes completely. The AI model you load into ComfyUI makes an enormous difference in the quality of your output. The gap between a generic model and an architecture-optimized one is immediately visible. For exterior visualization, Models fine-tuned on architectural photography and built environment imagery produce results that hold up to professional scrutiny. For interior work, models trained specifically on interior design imagery capture spatial atmosphere and material texture with a level of realism that general-purpose models simply cannot match. Both categories of specialized models are freely available on platforms like Civitai and Hugging Face, with active community documentation to guide selection. Prompt design is equally critical, and architectural prompts follow a different logic than general image prompts. Always be explicit about materials using technical terminology: exposed board-formed concrete, wide plank white oak flooring, structural silicone low-E glass curtain wall. Specify lighting conditions with equal precision: soft diffused north light, warm artificial evening illumination with candela contrast. And do not overlook your negative prompt, including terms like cartoon, painting, lens distortion, blurry, warped perspective, as default exclusions reliably raises the architectural plausibility of every output you generate. Now it is time to connect everything we have covered into a single, repeatable production pipeline. The real power of ComfyUI is not in any one node. It is in the fact that once you design a workflow that works, every future project simply requires swapping the inputs. Your pipeline has 3 layers. The first is the input layer. Your SketchUp or Rhino scene view loads into the image input node, and a ControlNet preprocessor automatically extracts the edge lines or depth information your chosen control mode requires. The second is the processing layer. Your architecture-specific checkpoint model loads and receives the ControlNet conditioning signal. K-sampler settings of 25 to 30 steps with a CFG scale between 7 and 9 consistently produce high-fidelity, architecturally coherent output. Add an IMG2 IMG node at this stage, and you can feed in a reference image, a project mood board, a precedent photograph, and the AI will absorb its atmosphere while still honoring your geometry. The third is the output layer, a save image node with an automated file name pattern, date, project name, scene number, organizes every output automatically and maintains full version history without any manual effort. Export this entire workflow as a single JSON file and your whole team renders at the same quality standard from day one. Junior staff produce senior-level output simply by swapping input files. The workflows we have explored today: node structure, ControlNet integration, architecture optimized, model selection, and team-wide pipeline automation are not experimental concepts sitting somewhere on the horizon. They are production-ready capabilities that studios around the world are deploying in live projects right now. The firms that move first are redirecting the time they once spent waiting on renders toward what actually creates value: deeper design exploration, more responsive client engagement, and faster iteration cycles across the full life of a project. The competitive distance between studios that have made this transition and those still running traditional pipelines is not measured in months. It is measured in proposal wins and billable hours recovered. The global architecture and interior design industry is in the middle of a genuine capability shift, and the tools to participate in it are accessible, open, and ready to install today. What is the first rendering task in your workflow that you would automate? Drop it in the comments. Your answer will shape what we cover in the next deep dive.